In this example, we'll be solving a rational equation. So in order to solve a rational equation, what I'd like to do is find a common denominator that will allow me to change this from an equation that contains several fractions to one that doesn't. So if I look for our lowest common denominator in this expression, I've got a 4 in this denominator and an x in this denominator, and even though it's not written in, a 1 in this denominator. So an easy way to find the common denominator here would just be to take the two terms I see in the bottom here and multiply them together to get an expression of 4x. So what I'd like to do then is take each of these, the x over 4, and I'm going to multiply that by 4x. I'm going to take the 7 over x, and once again multiply that by 4x. And I'm going to take the 3, and I'm going to multiply that by 4x. Because it's an equation, I can multiply all three original terms by the same value without changing the equality of the equation. So when I do that, what I notice is going to happen here is I've got a 4 in the top and the bottom of this first part, so they're going to cancel. We've got an x here and here, so they will also cancel. And I have nothing to cancel here, so I'm going to have to multiply everything on that side. So what I'm left with is x times x, which will give me x squared, minus 7 times 4, which is 28, and that's going to be equal to 12x. So you see I have something that turned out to be quadratic here. So if I'm going to solve for x, we would like to have this equal to 0. So I'm going to say x squared, and I'm going to bring the 12x over and make that a subtract 12x. And I'm going to have minus 28 there as well. And that's equal to 0. So this is a product and sum factoring now. So what I need to know is, I want two numbers that if multiplied together will give me negative 28. But if I add those same numbers, I'm going to get a negative 12. So if we look at that, we're going to have 2 times 14 here and 2 times 14 here. And because the 12 is negative, that would imply that the 14 is negative. So factoring this, I'm going to have x plus 2 and x minus 14 equal to 0. So I'm going to use the zero product property now and solve each of these for x, giving me that x is negative 2 or x is 14. So before I can say both of these are solutions to the original problem, I would need to obtain my MPVs. Now I'll be using my original expression for this, and the only value I have to worry about here is the x in the denominator. So if x is equal to 0, then we would be unable to evaluate the original expression. Since neither of my solutions is 0, I can say that negative 2 and 14 would both be valid solutions to my original expression or equation.